Hello, maths lovers. Welcome to my channel. Today we'll be discussing number bases. I know most of you must have heard of this topic, and I just want you to understand something. Let me give you a little secret about number bases. Every natural number, when I mean every natural number, when you talk about 1, 2, 3, 2, whatever you count, they are in base 10. And when you want to write a number in base 10, example, I have 123, I can write it in words, 123 in base 10, or I will say 123 in base 10. So every natural number is in base 10. So it is either written like this, or it is written like this. So anytime you see numbers written like this, you're discussing about number bases, or you can say your number base system. Now when you are talking about number bases, you can convert from one base to the other base. You can convert from base 10 to base 2, you can convert from base 10 to base 3, you can also convert from base 3 to base 10. So we'll start with converting numbers from base 10 to base 2. So when you are converting numbers from base 10 to base 2, you have, for an example, I want to convert 123 in base 10 to base 2. 123 in base 10 to base 2. 123 in base 10 to base 2. If you want to convert from base 10 to any other base, you can make use of something called your long division method and always put the remainder at the end. Example, because I am converting to base 2, I would say 123, I will divide by base 2 because I am converting to base 2. Then I will divide this by 2. 1 divided by 2 is not possible. Not that it's not possible, but it is. I can just bring 1 and 2 to make it 12 because 1 is smaller than 2. So bringing this 1 and this 2 together, I now have 12. 12 divided by 2, you have 6. 3 divided by 2, it will go once and it will remain 1. You continue this way. So you also divide by 2. 6 divided by 2, you have 3. 1 divided by 2, just like you said, 1 is smaller, I can have 0. Then I have remainder 1. I divide 30 by 2. 30 divided by 2, so I start with 3 divided by 2, I have 1, remaining 1. 1 and 0 becomes 10. 10 divided by 2, I have 5. Because it has no remainder, I will say remainder 0. I divide 15 by 2. 1 divided by 2, you know how we've been doing it. So I join 1 and 5. So it becomes 15. 15 divided by 2, it goes 7 and it remains 1. So I divide 7 by 2, it goes 3 and it remains 1. I divide 3 by 2. I divide 3 by 2, it goes 1 and it remains 1. So if I divide this 1 by 2, divide 1 by 2, because 1 is too smaller, I'll put down 0 and it remains this 1. Now write my answer from down upwards. So what's my answer? 1, 1, 1, 1, 0, 1, 1. Now it is in base 2. So the first secret we've learned that every natural number is in base 10. Another secret you need to learn about base numbers is that when you're discussing base 2, when your numbers are in base 2, you can have numbers equivalent to the base and greater than the base. So if it's in base 2, you can have 2 in your answers. So if you're solving and you have 2 in your answers, know you're already wrong. So you look for where you got it wrong and try to fix it. So this is we converting to base 2 from base 10. So when you're converting from base 2 to base 10, you make use of this long division method and we get our remainders from bottom upwards. So we just converted from base 10 to base 2. And remember that we can also convert from base 2 to base 10. So for us to confirm that our answer is correct, let us also learn how to convert from base 2 to base 10. Now, this is our answer and I believe you have questions. So always feel free to ask questions here on this channel. So I will convert from base 2 to base 10. With your permission, I would like to go to this other side of the board so we can compare our answers. Now I want to convert. The answer we got there was 1, 1, 1, 1, 0, 1, 1. in base 2. So the question says convert 1111011 base 2 to base 10. So there are two methods of converting to base 10. There are two methods of converting to base 10. One is called the continuous multiplication method, while the other one is called the expansion method. So I'll make use of the expansion method. I'll make use of the expansion method first, then I'll also make use of the continuous multiplication method also. So our steps for the expansion method is, let's say, solution. I have 1, 1, 1, 1, 0, 1, 1 in base 2. So the first step, I will number from 0 and increase it towards my left hand side. So I have 0, 1, 2, 3, 4, 5, 6. You start from 0, you take up to your left hand side to where it stops. So I'll pick this first number, 1 times, what's my base? 2 to the power of the number you have on top of it, which is 6. And I will add. I have 1 times, what's my base? 5. Sorry, my base 2 and to the power of 5. Plus 1 times, what's my base? 2 to the power of 4. I also have 1 times, what's my base? 2 to the power of 3. I also have plus, I have 0 times, what's my base? 2 to the power of 2. Plus 1 times my base 2 to the power of 1. Plus 1 times my base 2 to the power of 0. Now, if you look at this, my base is carrying the power. Not everything in this bracket is carrying the power. So please don't make that mistake while you're solving. So let's learn. 1 times 2 to the power of 6. 2 to the power of 6, we all know it doesn't mean 2 times 6. It means 2 multiplying itself in 6 places. So let's look at the 6 places with my fingers. I have 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 32 times 2, that is 6 times, is 64. So I have 1 times 64. I can just put it in my bracket so you don't make mistake. But I believe if you continue with time, you will be very, very fast with this. So I have 1 times 2 to the power of 5, just like we did. We find out 2 to the power of 5 is 32. Plus 1 times 2 to the power of 4, you find out is 16. Plus 1 times 2 to the power of 3, you find out is 8. Plus 0 times 2 to the power of 2, you find out is 4. Plus 1 times 2 to the power of 2, you find out is 2. Because 2 to the power of 1, you find out is 2. Because 2 appeared once. Plus, if you remember in mathematics, when you have a number that is not 0, that is raised to the power of 0, is equal to 1. A number that is not 0, raised to the power of 0 is equal to 1. So let's add. 1 times this is 64. Plus 1 times 32 is 32. Plus 1 times 16 is 16. Plus 1 times 8 is 8. Plus 0 times 4 is 0. Plus 1 times 2 is 2. Then I'll add 64 plus 32 plus 1 times 1 is 1. Okay, sorry for that. So 64 times 32 will give 64 plus 32 will give us 96. 96 plus 16. 6 plus 6 is 2, is 12. 2, you carry 1. 9 plus 1 is 10. Plus 1, you have 11. So I have 112. 112 plus 8 will give us 120. 120 plus 0 is 120. 120 plus 2 is 122. 122 plus 1 is 123. So that confirms that this is as good as saying 123 in base 10. So looking at this, we converted 123 in base 10 to base 2, we got this. We converted this to base 10, we also got 123. So these are examples of base numbers, and we can also try the second method, is the continuous multiplication method. Feel free to ask questions on this channel. See you next time. Don't forget to subscribe. Thank you very much.